Pradesh MedTech Zone, AICTE Visakhapatnam. With over 16 years in the biomedical industry, he has significantly advanced India's medtech landscape through research, innovation, education, and skill development. At AMTZ, he leads national-level biomedical training programs through IBSC, also designed postgraduate diplomas, certificate courses, workshops, and industry trainings that bridge academia and industry and enable successful placements in the leading medtech companies. He is committed to building a skilled workforce for India's self-reliance in healthcare technology, and he mentors young professionals and champions skill-based training, and also focuses on the industry growth and global competitiveness. Thank you, sir. Thank you for accepting our request. Now you can start the session, sir.
Yes, ma'am. Thank you. I'm sharing my slide. Is it able to see the screen slides?
Yes, sir. You can keep in the presentation mode so that it will be large, maximized.
Yes. Yes. Is it okay? Fine. The slides are changing, right?
I'm not seeing the slide change. The first slide I can able to see, sir.
Madam, may I know the participants are from which colleges and how many states?
Yes, sir. I think Dr. Naidu will tell about it. I request Dr. Naidu to.
Okay, if you have any information, please share. Is it fine? The slides are visible?
No, sir. We can see you, but not the slides.
Sir, post the session, I will share you all the list of participants with you, sir.
Oh, no, sir. No, not about the list. And
so you can share the screen, sir. Yeah. Yes, now the screen is visible. No, it's bent.
Fine.
No, sir. Can you share the screen? Yes, sir. You can keep the presentation mode.
Right, okay, slides are more changing, right?
Yes, sir. Mode is not changed, sir. Just can you go for presentation mode?
It's in presentation mode only.
No, sir. It's not showing here in presentation mode. Can you go for F5? Actually, it's showing the slide 4. It's not in the first slide, sir.
Okay, slides are changing, right?
Yeah.
Sir,
Madam,
if you press the F5 key on your laptop, it will come in the presentation mode then. Hello?
Yes,
am I audible, sir?
Yes, you are audible. It's clear.
Sir,
it's in
I'm requesting you that if you press F5 key on your laptop or computer, then it will come in the presentation mode.
right? It's in presentation mode. Hello.
Still, it is not in presentation mode, but it's okay, sir. Through this, it is also visible clearly.
Okay, the slides are changing, right?
Yes, sir. Yes, sir.
Yeah. Okay, thank you. Sorry for the delay, and thank you for this opportunity to Naidu sir and to the department. And I am Naresh Kumar, a biomedical engineer by qualification, and I am working in AMPZ, Andhra Pradesh Medtech Zone, then a scientist E, and head for the training division. It's an Indian Biomedical Skill Council. And I like to give the brief about our AMPZ ecosystem. For those who are not aware about the AMPZ, I request you to please visit our website, AMPZ Andhra Pradesh Medtech Zone, so that you will get some information about our organization. And also I shared the one YouTube link in our this chat box also to the Pavani ma'am, Dr. Pavani ma'am. Request you to share it to the faculty groups as well. So in AMPZ is a state government enterprise. It's a public sector enterprise initiated by AMP Andhra Pradesh in year 2016 and started functioning in the year 2018. In this last 6 years of operation, it's established the almost 18 plus scientific laboratories and 165 plus medical device manufacturers. And we have the complete ecosystem suitable for the medical device manufacturing. In a simple way, if we say the general industrial zones or industrial parks or SEZ, whatever it is called, government will allocate some land and give us some tax benefits, road, water, electricity, the basic facilities, as well as SEZ means some special economic zones where the some tax exceptions will be there. That's it. It's not about the creating the some ecosystem. And this is one best example for the other sector also. Like we have the clusters only, electronics cluster or automobile clusters in Tamil Nadu and other cities we have. But for the medical devices, if you see specifically for the medical device, this is the first of its kind in India, where it's an example, sets an example for the creating the such type of the medical device parks in other states. Even the central government also taken this project, integrated model, and creating the four such type of the parks in four different states in Tamil Nadu, Madhya Pradesh, and Uttar Pradesh and near Noida, it's near to Delhi, and Uttarakhand. These are the four government initiatives in addition to the central government initiatives. The other states like Gujarat state in the Rajkot and in the Telangana state in Hyderabad also have created the medical device parks. So in our ecosystem, the required facilities to the medical device manufacturers is supported, it is created by the AMDZ. For a simple example, like medical equipment, it requires it includes the electronic equipments like ECG mission, ventilator, start from the glucometer to the high-end MRI missions. The different type of electronic equipments will be there. The second, one more category will be the implants, like the stents, medical implants, the hip joint, knee joint, these type of implants. If any dental manufacturer is there, dental screw manufacturer, it will require say some around 1000 or 1500 SFT. Clean room is sufficient for machining the dental screw device, the small device. Once that screw is manufactured, that to be go for the biocompatibility studies. That is required again testing laboratory. So here for the electronic equipments, electronics testing like EMC, EMI testing facility is available inside the campus. For the implant manufacturers, the biocompatibility testing facilities is available. Once the product is already the product is manufactured, then to go to the patient, the pacemaker or the implant that to be sterilized. Sterilization, the gamma facility sterilization, that is also available. So we have almost 18 variety of the laboratories are available, supported by the various ministries and departments from central government. And we have the institutions also. It's a complete ecosystem, BioValley, MediValley, it's a startup councils supporting for the medical devices, biology, and the life science sectors. And in this area, we have the one department that is called IBSC, Indian Biomedical Skill Council, where I am the head for this one. And the objective for the IBSC is in our system, it's a manpower requirement is once the manufacturer is set up the facility, at the end it's required the workforce to work in the manufacturing industry. Once the product is manufactured, that to reach to the customer, the hospitals, it's required a supply chain, the sales engineer, the service engineer, the hospital biomedical engineers, the various job opportunities will be there. In manufacturing, if 100 employees are working, in outside the manufacturing, it's required at least 500 employment opportunities. Employees are required to do the sale of the medical equipment, service of the medical equipment, maintenance of the medical equipment. So this is in a one new sector. Medical device sector is in a one new upcoming sector. We see the examples like the earlier the pharma sector in late 1990s started. Now it's 35 years of the journey, and it's an already established as a world #1. We do the production, highest production in the world. It's in a top one. And IT sector started in the early 2000, and now in the 25 years of the journey, it's established itself like creating the more employment opportunities. The same way, the medical device parts, as of now in our AIMTZ, it's created employment opportunities of 7,500 employment opportunities within our zone into 5x in the outside the zone. So overall, we have almost 10 plus medical device parks in our country is proposed. So it will create the 2 lakh employment opportunities in the manufacturing sector and approximately 10 lakh employment opportunities in the outside the manufacturing sector. And IBSC, MTZ is created the IBSC the skill program to cater to the medical device sector for the medical device manufacturers and outside the industry. The objective is there is no such type of, even the colleges also. If you see the entire Andhra Pradesh state, we have the only Vignan University is offering this biomedical engineering course. We have out of 700 engineering colleges, there is only one university is offering this course. And if you see in the overall across India, only 145 colleges offering this BTech in biomedical engineering course. It's only. And out of that, majority is from the 50 to 60% is from the south part only, Tamil Nadu and Karnataka, Kerala. This is 50% of the colleges offering, and very few colleges are offering in the north side. Huge demand is there in this area. We designed and integrated the programs to the students. Start from the second year of their education. It's not like completing the education and after going for some skill training program and going for the opportunities. Also, during the education itself, we impart these trainings on the medical equipment handling and how to use the equipment, how to connect to the equipment, how to repair of the equipment in the different categories, critical care, the operation theatre equipment, the categories twice. Like second year, they will take a one. After the third year, they will take the another level. Finally, they will go for the job opportunities. And not only for the biomedical domain, these are the usable suitable for the EEE and the ECE and the electronics and communication domains also eligible. And we also offer the one more program for the students in the full semester exchange program. It's the same like the abroad exchange program. Like how the students will go to the one full semester abroad, the same way they will come to the AIMTZ industry. It is not only for the medical devices. We have the various categories of laboratories are there for the not only for the biomedical, mechanical, ECE, EEE. We also have the mechanical students also. We have the additive manufacturing facilities there. In the part 2 of my presentation, our technical officer, our scientist, Mr. Mahesh will share more details about our ecosystem, our lab system, or 3D printing laboratory system in AIMTZ. So, this program, particularly the full semester exchange program, we have almost 45 modules. The courses, it's called network courses. The candidates will select that one, and they will undergo the coursework. And we have the faculty, and we have the laboratories, and we conduct the examination also. Currently, the one college, students from the one college, they joined for the full semester exchange program. Earlier, it's like a option based. Now it is important in their education. The full semester, the students are spending the time at UTZ. We have the hostel facilities also available at in our campus for the separate boys and the girls. And these are the various job training programs in the medical devices area. And the students are visiting to the AMPZ regularly, weekly, 3 to 4 visits will be there. And every year, approximately 10,000 plus students, they visit the AMPZ regularly. From across India, it's not just only from the Andhra Pradesh state, it's from different states. We also offer the various programs for the medical device. For this, we offer the programs in 4 categories. One is for the students, one is for the faculties, one is for the working professionals, and one is for the medical device manufacturer. These are the 4 categories. We use our 18 laboratories and we conduct the program. This is the one specialized program. X-ray service training program is the only unique program. AMPZ is the only organization in India offering this program. And during the summer break or short-term programs, also like weekly programs, the value-added courses, depending upon the college requirements, we conduct the short-term programs to the candidates, and the same programs will be offered to the faculties. You can see these are the programs for the faculties. Programs in the 3D printing for medical applications. We focus on the medical applications. We have the laboratories as for the general applications like material science as well as the biomaterials. So we are specialized in the medical device category. And this is the one FDP program for the assistive technologies. We have the in-house assistive technology center is available. So for the students and the faculties, for the research purpose particularly, we support that one in the faculty areas of interest. And for the electrical safety laboratories, we have the EMC and EMI laboratory available for the ECE and the EEE domain candidates and the faculties. And these are the other programs, including the pharma domain also. We work with all engineering, pharma, MBA, and diploma engineering domains. In entire Andhra Pradesh, we have the only one temp facility available in at AMPZ campus. We conduct regularly the short-term programs. Any interested faculties, they can also utilize this research purpose. And we will also offer the students 1 month based internships to the students. These are the programs for the manufacturers related to the medical device industry, medical device quality management system, and the medical device regulatory affairs. And we also have the partners of around 150 plus partners, universities. We signed the MOUs. We welcome to all the colleges, universities, institutions, faculty, the diploma. We have the participate with polytechnic colleges also. We support. We always say welcome. Our motto is never say no to work. And the objective for the MOUs is we have the 18 plus laboratories covering the multidisciplinary, pharma, medical, engineering, MBA, mechanical domain, electrical domain, biomedical domain, including the computer science also. The application is at the end, the computer science, the integration is required. For the students level programs and for the faculty FDP programs, faculty research, and for the institutions, the joint programs and the collaborations, the workshops, the seminars. These are the objectives for the collaboration, and I will be the single point of contact for AMPZ. And I am Naresh Kumar, so faculty can share my details to the any institution, interested institutions. Thank you so much for this opportunity. I request Mahesh Garu, if you are in the session.
Yes, I am here.
Please continue. I am here only.
Yeah.
Can I take 1 or 2 questions, if anything, related to whatever I presented, if any? Okay. Mahesh, can you proceed?
Yeah. So I just want to show my presentation. So can you please share the screen? I'll share it there. Please give me the access to share the screen. Hello, am I audible?
Yes,
Yeah,
yes.
audible, sir.
Yeah.
Audible, sir.
Yeah, I just want to share my screen. So
Mahesh, sir, is it okay that can you? Ah, right. Okay. Okay. Able to see. Yes. Yes.
so is it visible?
Yes. Yes. Yes.
Yeah. Hi, my name is Mahesh. I am taking care of this what we call it sales and services of this 3D printing, CNC machining, and injection molding. So I want to explain what is 3D printing, what is CNC machining, and what is injection molding. Actually, all three are related to each other. So first thing is introduction. So evolution of manufacturing process. Manufacturing has transformed from manual craftsmanship to fully automated, digital driven products. Each stage improved such speed, accuracy, and scalability, leading to modern methods like 3D printing, CNC machining, and injection molding. Roles of 3D printing, CNC machining, and injection molding in industries. 3D printing enables rapid prototyping and customizations. CNC machining ensures precision and durability in critical parts. And injection molding is for mass production. Through they form the backbone of modern manufacturing across medical, automotive, aerospace, and consumer industries. So what is additive manufacturing? So another name of 3D printing is additive manufacturing, building objects layer by layer.
Hello, Mahesh,
To
sir.
STL, and that STL file we put it in our software in 2D file. So that because the printer will only read 2D files, so the slicing software is dedicated to the printer. So whatever printer we are using, it depends on the printer's orientation. So 3D printing have multiple technologies like FDM, SLA, SLS, DLP, DMLS. These all are like the actually the first 3D printer innovated was SLA, stereolithography. That is photocurable resin. So in these all technologies, we can use different type of materials, and we can't use the same material in every technology. So FDM, just like in FDM, we can use ABS material, PLA material, TPU material. In SLA stereolithography, we can use ABS photocurable resin. And in SLS, we can use nylon material. The grade is PA22200. In DLP is mostly famous for small components like the jewelries items, means details we can achieve, but in DLP very small components we can manufacture because the bed size of that machine is very small. And in DMLS, it's a direct metal laser sintering, so we can produce up to 400 500 dimensions of product we can manufacture. Why 3D printing is famous? Because we can make the complicated parts also, in which we can't achieve in CNC machining or injection molding. So fuse deposition modeling, we call it FDM. So it's a 3D printing process where thermoplastics, filament, the raw material comes under filament form. So the filament is, the extruder should be there, where the filament is heated and it melted the material and it deposits layer by layer to build that part. So we can use materials, multiple type of materials like PLA, polylactic acid, ABS, PETG, nylon and TPU, but with the limited grades only. So the advantage here is we can produce the part within a day. So the cost of the material is very less, but the finishing is not that good because this is the basic 3D printing technology. So good for prototype. If you want to test a product, it's good because the cost is very less. Wide material availability. The material is easily available on this particular FDM technology. So limitations, visible layer lines, because this is the lower cost 3D printer. So the formation is visible in it, and not ideal for very strong or high precision parts. The tolerance we can't achieve more. We can achieve only plus minus 200 microns. If you want very precise product, you have to go with CNC machining. We can't manufacture the precise means 0.5 means 5 micron, 10 micron and tolerances we can't achieve in 3D printing. We can achieve plus minus 200 micron. That is the tolerance we can achieve. So applications for this is basically used in prototyping. If you want a model within a day, or if you want to test basically we use this to do the medical devices to produce a prototype. First we have to go with the prototype. After that we can do the production. If you have any design changes, you can easily go with this to check it visibly whether the design is fitting properly or not. So educational models, mostly this dental maxillas, mandibles, these all the doctors do trials on this. They give us the order that we provide them the maxillas and mandibles so that they can physically check on the product so that they no need to do the experiment on the patient itself. So the jigs and fixtures, as I told you, the cost is very less. Custom consumer product. So this is a customized consumer product. If you want to change a design, you can easily change and get it within a day, the product. This is
Hello, sir. Hello.
Yeah, tell me.
The slide is not moved, sir.
No, now I think it is moved, right?
No, sir. Can you check once, please? Okay, sir.
Okay.
Yes, sir. Yes, now it's visible.
It is moving.
Now it's moving. Yes, sir.
Yeah.
Okay, thank.
Okay. So now this is stereolithography, SLA slide. It is visible, right? Hello. Hello, am I audible?
Yes, sir, you are audible. Continue, sir.
Yeah, the slide is visible, right?
Yes, sir, the slide is visible. You can continue.
Thank you. Stereolithography, basically it is a 3D printer, a 3D printing process where UV laser cures liquid resin. The raw material comes under liquid form. So where we can use the UV laser to, here we can use the good tolerance, not plus minus 200 microns, but we can achieve less than plus minus 100 microns. So we can achieve. So it comes with basically medical products we make in this this technology only, with this technology. So advantages are high accuracy and fine details. The smoothness, here you can't see the layers. This is also a layer by layer formation, but after printing the layers are not visible itself in the product. So the surface is very smooth, ideal for complex geometries. So here in FDM and stereolithography, both the supports come. So while printing, if some more than 45-degree angle any exposing is there, then the printer itself put some supports so that after some height, if some material they have to pour, then with the support of that support, it can produce it can deposit the material there. So the applications here is the limitations. Resin cost is higher than FDM filament. Why that point is mentioned is in FDM also ABS material is available. In stereolithography also this ABS material is available. But here the finish is very good and the raw material is little costly compared to FDM's ABS material. So part may be brittle depending on resin type. So part is little brittle, the strength is very less. And post curing and handling required. Actually, we do once the print is done, after removing the supports, we do curing process for this so that it little bit strength will be more after printing. So applications, dental and medical models, all 3D printings are mostly dedicated to medical. So jewelry casting patterns, if the part is, if not that good details are there, we can go with SLA technology. High precision prototyping, as I told you, that plus minus 100 to 200 micron we can easily achieve. Functional part with fine details, yeah, because the layers are not visible, we can easily find the details here. So in the other slide, DLP, digital light processing. This technology is particularly dedicated to jewelries because here you can achieve very small details, even 0.05 mm also you can achieve in this, but with limited height and limited dimensions of the part. So this is a printing technology, digital light projector to cure an entire resin layer at once instead of a laser. This is a photocurable resin. So material, photopolymer resin, standard, castable, dental. So here we can use the castable resin also. So advantages, faster printing than SLA, cure fully, layer at the time, high accuracy and smooth surface finish, great for small detailed parts. But the disadvantage here is the part is very brittle. If you press it, it will break. So that is the disadvantage here in DLP material. So that is why whenever you want to go with a castable thing, then only they prefer that these details will come while they do the casting. So limitations, limited build size compared to other methods because the bed volume is very small. Resin can be costly and required handling precision because the material is very delicate. Post curing and finishing needed. Yeah, the same process like SLA. Once the printing is done, we do the curing process for this. Applications, basically it is not recommended to dental, but jewelry casting pattern we can suggest, and miniatures, yes, we can suggest it. DMLS, direct metal laser sintering. In this process, we can use multiple materials like ALSI 10 mg, we can use aluminium, that is a grade of material which we can use. See here, I mentioned that stainless steel, aluminium, titanium, chrome, inconel, these all materials we can use. But till now, these all are not can't be used in DMLS with 100% accuracy because these all come when you go with 3D printing. These all comes with alloy. Some mixture is there which we can use. So dedicatedly, when it comes to SS material, we can print aluminium. When it comes ALSI 10 mg, that particular grade of material we can use. So like that, titanium, in titanium also some grade is there which we can use. So limited only materials are there, but it is all the materials are approved medically also. So in medical products like implants and everything, basically we use this titanium particularly. So advantage, produce strong, dense and functional metal parts, enable complex geometries not possible with machining. Yes, in machining we can achieve limited, but here why we can achieve more complex parts? Because of this layer by layer process. If some inside some if you, in an example, if you kept a ball, inside one ball another ball can be printed. Inside one hollow ball, we can print another hollow ball inside in this process in 3D printing. But in CNC machining or injection molding, we can't do that. So these all things are can be easily achievable in 3D printing. So limitations, high equipment and material cost. Yeah, the cost of the material is very high. Requires post processing, heat treatment and machining polishing. Yeah, because the supports comes, the minimal support comes. So once the printing is done, we have to remove the support. Because of the weight of the material, we have to remove it from the build plate with EDM process or some of the process of we have to remove. After that, we have to do the heat treatment also to strengthen the material. Slower than traditional manufacturing for mass production. This is not suggested for mass production because the product cost is very high. So basically
sir.
aerospace.
Hello.
Yeah.
Again, that slide is not moving, sir. Please check once.
No, I am explaining this slide only, DMLS.
Okay. One message is coming from the chat box. That's why I will ask you.
Okay, okay. But I am explaining about direct metal laser sintering. Is it visible, right? That slide is open.
Yes, sir. That
Yeah.
3D printing technologies, that slide is open, sir.
So is it there? DMLS, direct metal laser sintering, is that slide is open? Is it visible?
No, sir. All the technologies are, that slide is open, sir. FDM, SLA. Now it's clear, sir. DMLS.
Okay. So
Okay, thank you.
okay, so now these can be used structural parts, medical implants, customized titanium joints, dental implants. We can easily manufacture in this. Once we do the, actually in DMLS, the posture will come like a grainy finish, because we use the powder material with which the grainy finish will come. So once we print the material, we do the hardening with heat treatment process. After that, we go for CNC machining for the outer surface finish. So tool and mold with conformal cooling channels, because inside cooling channel is required, which can't be do by CNC machining. We can easily print it in 3D printing if the cooling channels are required. So in the same thing, this SLS, selective laser sintering. Another one technology is there which I didn't kept in the slide. That is MJF, multi-jet fusion. So both are same. In both technologies, we can use nylon material, but in SLS is little bit flexible and MJF little bit less flexible compared to SLS. So in SLS, we can use material like glass filled nylon, aluminum filled nylon TPU, and nylon PA2200. Here the advantage is strong, it is durable, and functional parts we can easily achieve. No need for supported structure because the powder weight is very less. Okay, it is a nylon powder which is very less weight. So here in SLS and MJF technology, the support is not required. Without support, we can print the part. So basically that is why if you see the market, most of the products manufactured by SLS and MJF only, because the supports will not come. After printing, you can remove the material, remove the excess material, and you can use it directly wherever you want. So this is good for complex geometries and moving assemblies. So limitations, higher equipment cost. The equipment cost is very higher, and most of the machines are made by German or US. And the rough surface finish needs post processing. Yeah, because of the powder material, the finish will come grainy, but you can give some post processing with some sandpaper, or if you apply the sandpaper on that, it will come very nice. So slower than injection molding for mass production. Yeah, injection molding is for mass production. If you want for prototype, then you have to suggest SLS, or else you can go with injection molding, because injection molding is the best finish you can achieve. So applications, aerospace and automobile functional parts we can easily achieve. End use components, we can directly produce and use the components. No need to do post processing, more post processing or anything on it. Tooling and fixturing, yes, fixturing we can make. Medical implant and prosthetics, mostly used for prosthetics because
Slide
it
is
comes
not moving.
after printing, flexibility will be there. Yeah, I think DLP already I explained, DMLS explained. So the applications, yeah, it is basically used for prototyping. If you want to check the prototype of the product, initially it's better to go with 3D printing application because the cost is very less. After that, if you want to go with 30 or 40 or 50 units, if the product is not that complex, then you can go with vacuum casting, or else if the product is very complex, then you can go with 3D printing. Customized medical device, prosthetic implants, we can easily manufacture in 3D printing. Manufacturing molds for injection molding. Injection molding mold, if it is very complex, then we can manufacture it using 3D printing technology. Complex geometry not possible with traditional method. As I told you, the things which we can't achieve in traditional method, means CNC machining process, we can easily achieve in 3D printing. So this is CNC machining. Here, the till now I explained you adding layer by layer a material we are pouring, or else laser is creating the object. Somehow we are adding layer by layer. Now I am explaining CNC machining, which is
The slide
subtracting
is not
the
visible,
material.
sir.
Now also it is not visible.
Yeah, yes, sir. Now also it is not visible.
Uh,
It's visible, sir. Hello?
yeah,
Yes, sir, it's visible. You are explaining about CNC machining, right, sir?
yes.
Yes, sir, it's
So,
visible, sir. You can continue,
okay.
sir.
Okay, so this is a process where we can use the block of a material. With multiple materials, we can easily we can do machining on any material, any metal or plastic, whatever the material is, we can use it. Here in 3D printing, limitations are there. Few materials are only available, but in CNC machining, whatever material is available in a size of block or else in a size of rod or else something, if it is there, we can make the component using that material. So this is a subtracting process. So where we with certain tools we do the subtracting. We remove the material from that solid block. So what is CNC machining? Subtracting manufacturing process removes material from solid block using cutting tools controlled by computer, CAD, computer aided design, CAM, computer aided machining, CNC, computer numerical control program. So in CNC, multiple processes are there, in which I mentioned milling, turning, and electric discharge machining. So what is milling? Milling is a subtracting manufacturing process where rotating cutting tools remove material from a workpiece to create the desired shape. How it works? CAD model prepared. We should have the 2D drawing of the component which we are going to manufacturing with the tolerances, what we have to achieve. Here we can achieve 5 micron also. Even 1-2 micron also we can achieve tolerance. So CAD file should be there with which will be with the support of CAD file we do the programming, computer aided manufacturing, which we load to the machine, workpiece fixed on the machine bed, cutting tool rotates and moves in the multiple axis x y z directions. Other 5-axis machine, 7-axis, here I mentioned 3-axis machine, but 5-axis machine, 7-axis machine is also available. With the support of that, we can cut the material and material is gradually removed to form the part. So advantage here is high precision and repeatability. The precision is very high. As I told you, we can achieve 5 micron, 1 micron, 2 micron, this much tolerance also we can achieve. So handles metals, plastics and composites also. Can produce complex 3D shapes. If you go with 5-axis or 7-axis machine, some of the 3D shapes we can easily achieve. So excellent surface finish, because it is a machining part. You can the best quality. If you want to go with metal, you can easily achieve the best finish in the market. So limitations, high material waste. Yeah, in subtractive, what here it is mentioned, high material waste compared to additive methods. In additive method, no need to waste the material. We can reuse the material because it is in powder form. Once the component is created, we simply remove the excess powder from that component and we can use that powder in the next build also. In the next process, we can use the same powder, adding some powder, some margin should be there, virgin material with non-virgin material. We use it continuously in additive manufacturing. But here, the removed material, we can't use it again because we want solid block for milling, turning, whatever in CNC process. So set up tooling cost for small quantities. If the quantity is very less, actually we do fixtures. If the fixture means to hold the part. If the component is little complex, we use fixtures. We make one fixture to hold that part which need to be manufactured. So if the quantity is very high, whatever the fixture we made, we can use that fixture for multiple products. So if the requirement is very less, we have to charge the fixture also. If the quantity is very more, No need to charge the fixer, because if just fixture charge is 100 rupees, if we are making 100 components, then each with one fixture we can make 100 components. So 1 rupee only it is charging for the fixture. If you want 2-3 products, then if you want to make one fixture, then it is costing around 50 rupees if you want to go with 2 products using one fixture. So that is the thing here. Setup and tooling cost for small quantities. Applications. Automotive engineering blocks and gear part easily we can manufacture. Aerospace turbine blades we can easily manufacture. Medical surgical instruments. As I told you that we can easily achieve 1 to 5 micron also. So medical surgeries instruments need to be achieved as much as tolerance, minimum tolerance. So mold and die making, as mold making can be possible in CNC machining mostly with the support of 3D printing also. But to make a mold, the accuracy should be very minimal, because as good tolerance you get, the product will come out as good as possible. So the turning, milling and turning, two things are there. In milling we can do the 2D step by step. The block we can use in milling process. In turning we can only use the circular parts, means the rods, and means I can yeah, we can make the circular jobs here. In milling we can't do the circular jobs. In turning we can do the circular jobs only. In milling we can do the rectangular or else this triangular jobs also we can make. In turning we can only do the circular jobs. So CNC turning is subtractive process where a workpiece is rotated with a cutting tool, remove material to produce cylindrical parts. How it works? Workpiece is clamped in chuck and rotate at high speed. Here the workpiece will move, but in milling the workpiece will not move, only the tool will move. So a stationary cutting tool move along with the surface. Material is removed to achieve the desired diameter, grooves or threads. Basically screw type parts or else this circular cylindrical jobs we can easily do in turning. We can't do that job in milling. So advantages: ideal for symmetric cylindrical parts, high accuracy and repeatability. As I told you, in CNC process we can easily achieve high accuracy. Faster than milling for round components. Yeah, because here the component is moving, the product is moving, we can this is little bit faster compared to milling process. Can produce both external and internal features. Yeah, we can do the external and internal features using different type of tools. So limitations: limited to parts with rotary systems, symmetry, complex shapes may require secondary options. Yeah, if some complexity is there, once the turning job is done, we can use the same product in milling to do that complexity. So applications: shafts and axles, bushes and couplings, screws, bolts, threaded parts we can easily manufacture. Hydraulic and pneumatic components we can manufacture using turning machine. So EDM, electric discharge machine. Here the EDM is a non-traditional machining process where material is removed from a workpiece using controlled electrical sparks discharged between an electrode and the workpiece. So how it works? A tool, electrode and workpiece are submerged in dielectric fluid. The fluid, the oil will be inside to cut the material using so that the electrode will not get heat that much. So the oil will pass the current in between the electrode and the component which we are manufacturing. A voltage is applied generating sparks. Sparks erode tiny amount of material from the workpiece. Very small amount of material it removes in one step. The process repeat to form the required shape. So type of EDM, two types we have: die sink EDM, wire EDM. Wire EDM is basically using for cutting, and die sink EDM we uses to make complex shapes. So advantages: can machine very hard material, titanium, hardened steel, which can't be. If we use we can manufacture, we can use hardened material in machining also, but the tool will easily wear out if we use milling or turning process. But if the material is very hard and we are using EDM process, then the tool will not wear out easily. So produces interact shapes and fine details. yeah, the tolerances is like 1 to 2 micron only, easily we can achieve. That is why we use this process to make the molds. No mechanical stress on the part, no cutting force, because it is not directly contacting to the part. With the support of oil, it is contacting. So limitations, slower than conventional machine. Yeah, the very less amount of material will be removed at a time. High high energy consumption. Yeah, it takes more energy. Limited to conductive materials. Applications, mold and die making. Basically using this technology, we make molds. Aerospace turbine components, because more accuracy should be there. That is why we are using this technology. Medical tools and implements also, depending upon the complexity, we decide that what technology can be used to make the components. CNC applications, high precision parts, we can easily achieve. Aerospace and automotive components, we can achieve. Medical devices components, depending upon the complexity. Dies and molds, mostly we can do with CNC machining. So now I am going on the slide, injection molding. What is injection molding? Manufacturing process for mass production of plastic parts. Here we can use multiple type of plastics. Even injection molding can make metal components also, but we are not that much, we are not working with that. So I don't have that much knowledge on that particular thing. But in this, what we call plastics, we can use multiple type of plastics here, depending upon the component, depending upon the usage of the component where we are using, we can finalize the material which we can use, because molten plastic injects into the mold cavity. We can make the core and cavity. It will close. The core and cavity will close. Some chambers will be there inside which the raw material will flow and make the part. So process is mold, design, clamping, injection, cooling, ejection. While the cooling is, first we make the mold. We put the mold in the injection molding machine. After that, we clamp it so that the mold, the core and cavity can easily open. After that, once it fixes, we can close it and inject the material. Once the material is injected, it will cool down for some few seconds. After that, the mold will again open and the part will come out with the ejection process. So type of injection molding, this we can use thermoplastic molding, thermoset molding, over molding, multi-shot molding. So depending upon the component, if the component is, we have to put the component and after in the top of the component, we have to pour some material. We can use that over molding process to make that component. So once we see the component, we can identify it. So applications of injection molding, packing industries, automotive components, consumer electronics, medical devices, all we can make. But in injection molding, when we use injection molding, see, as I told you, if you have the requirement of more than 1 lakh components, then you can suggest this injection molding. Because with one mold, it will cost around 50-60 lakhs, depending upon the part size and complexities. But if you don't want to go with 1 lakh or 2 lakh components, it's better to not go with injection molding, because with one mold you can achieve more than 1 lakh units. So if you want to go with less quantity, it's better to go with CNC machining or vacuum casting. If you want to go with prototype, it's better to go with 3D printing. So depending upon requirement, we select whether it's better to go with 3D printing or CNC machining or injection molding or vacuum casting. These all technologies are equivalent to each other, but depending upon the requirement, we will fix it. So 3D printing, best for prototypes and complex shapes. CNC machining, best for precision and durability. Injection molding, best for mass production. Because if you don't want to go with mass production, it's better not to go with injection molding, because the cost is very high if you don't go with mass production. If your quantity is very high, in 3D printing, if you are making one component in 10 rupees, in injection molding, you will easily get it in 10 paise, but the requirement should be very high. It should be more than 1 lakh, 2 lakh units. Then only you will achieve it in 10 paise. In 3D printing, if you want one component, you can easily get in 10 rupees. So that thing we should decide upon our requirement. So choose the method based on quantity, material, design complexity, cost. These all are depending on the requirement what you have. So this is comparison 3D printing, CNC machining and injection molding. 3D printing ideally for prototype and low volume. Complex design possible. CNC machining high precision and durability. Works with metals and plastics both. Injection molding best for mass production. High initial cost but low per part cost. Initially it will cost high because the mold will cost high. Once it is done, you can run the mold for 2-3 years. For more than 10 lakh, 20 lakhs also you can, depending upon core and cavity, we will decide how many cavities we can produce. If the requirement is high, we can go for 32 cavity, 64 cavity mold also. So yeah, hybrid manufacturing, 3D printing is basically day by day, it is growing so many different within a year, within a 2 years, so many updated printers are coming because of this R&D. Subtractive material recycling, you can't recycle it, that is the sustainability, and increasing use of 3D printing and end use parts. So 3D printing is basically for prototyping. We can easily get the product within a day or two. So yeah, this is the thing which I explained you. So if you have any questions, you can ask me. Hello.
Thank you, sir. Participants have any queries? Ask him.
Yeah, you can ask me or you can contact my colleague, this Naresh Garu, also for if you have any requirement, like if you have any prototype to make or else whatever, if you have any product if you have any idea, you can contact us. We have designing services also. We have 3D printing services. We have injection molding, vacuum casting, CNC machining. We are end to end. We can deliver end to end product.
మధ్యాహ్నం ఉంటుంది ಸ್ವಲ್ಪ ನಿಂಬೆಹಣ್ಣು ಇರ್ಬೇಕು ಕೂಡ ಟ್ರಾನ್ಸ್ಫರ್ ಸ್ಮೂತ್ ಹೇಳಿ ಹಂಗೆ ಒಂದು ಹೇಳಿದ್ದಾರೆ ಮಂಚೂರಿ ಹೇಳೋದು ಪೆಪ್ಪರ್ ಡ್ರೈ ಹೇಳೋದು ಗೊತ್ತಿಲ್ಲ ಪೆಪ್ಪರ್ ಡ್ರೈ ಮಶ್ರೂಮ್ ಪೆಪ್ಪರ್ ಡ್ರೈ ಅಲ್ಲ ಗೋಬಿ ಅಲ್ಲ ಮಶ್ರೂಮ್ ಪೆಪ್ಪರ್ ಡ್ರೈ Sir, this session is completed.
Yeah, if anyone have questions, please ask me.
Sir, I think there are no doubts from the participants. It's an informative session, sir. Anyway, we will share the contact details with the participants. They will ask if they have any doubts, they will reach you.
Yeah, sure.
Thank you, sir.
Sir. Hello. Hello, sir.
Yeah,
Hello?
tell me.
One question is came from chat box.
Okay.
What are the challenges in printing, sir?
Yeah, as I told you, a few complexities are like depending upon the component, we can visibly identify that which see, when we make the designing, we just the designer should know that with which technology we are going with. So depending upon that, he have to do the designing. If the designing is not done with the next step, thinking about the next step, then few complexities will come. Like if you are making a hollow product, see, if you are making a hollow product in 3D printing, and once the printing is done, we have to remove the material from it. So now no gap or no hole is there. Nothing is there to remove the material from there. So that type of complexities will come. So that is why whenever the designer is doing that designing, so he should know that what technology we are using to wall thickness 1 mm. So why? Because we can easily achieve 0.5 also. But why we mention 1 mm is 1 mm we can easily achieve. 0.5 is little bit complicated for us. I can give you one example that the surface is 5 mm thickness, one surface is there. On the top of that, if you are putting some wall while designing, so if the wall thickness is 0.5 mm till 1 mm, you can easily achieve. But if it is more than 1 mm, 2 mm, 3 mm, it's quite difficult to achieve because the wall will not stand on that. While printing, it will fall down. So that is why the wall thickness should be minimum. So while making the design, we do these all things, that with which technology we are going with. So depending upon designer, we can go, and if the designing is done and the technology is decided after designing, then we have to change some designings to achieve in 3D printing. Yeah, hello.
Okay, sir. Thank you.
Thank you.
Welcome.
Thank you, sir. You may leave now.
Thank you.
Participants, everyone leave the session.
So those who wants to give the feedback can stay back, and who doesn't need the attendance can leave. Thank you. Dear participants, the feedback link, which is revised one, is shared in the chat box. You can fill the form now. The submission button is also enabled now. If you are still facing any problem, please let me know. I'm staying in the online. Thank you.